Hello. First of all, I would like to say happy anniversary to the oldest of Yakir's ideas. It's been great pleasure working with Yakir over the last 4 years, and he's caused us a lot of fun. We've had a lot of fun with him, and we hope to have cause him a little fun in the next few months. This idea arose out of an experiment that was done where I work about 12 years ago, one of the first weak measurements. And my colleague Dan Parks, as part of doing this, introduced an idea of called weak energy, pointed weak. Okay. Pointed weak energy, of which this is one definition. And basically, if you take the time integral of the weak energy, it's the sum of the dynamic phase and a purely geometric phase, the pointed geometric phase. And for cyclic evolution, it's just the geometric phase in the same sense the Aharonov-Anandan phase is. And pointed weak energy can be expressed in terms of the associated Pontryagin phase, chi, and a Fubini-Studi metric, the distance that was introduced in one of Aharonov-Anandan's papers about in the late 80s. These provide a general set of coordinates that represent quantum state evolution in a Hilbert space of an arbitrary dimension. Oops, backwards. This is like the other left. And basically the consequences of this, which are demonstrated in a number of papers that have been published in the Journal of Math Physics over the last 10 years, are these. Basically, the point of weak energy, you can define an Euler-Lagrange equation for it, as well as define a stationary action principle. And it describes a non-unitary evolution of correlation amplitudes, as well as you can talk about temporal persistence of the state of normalization and various mathematical properties. Basically, it gives you a one-form invariant, and all the details of this are in the poster or in the papers, and that's the summary.
Thank you very much.